You know, when you stand outside, the ground feels, well, solid, right? Like it's been there forever. But what if I told you it's actually a massive slow-motion construction site? The Earth's surface is constantly being built up and torn down. It's this incredible story written in rock and soil. So yeah, let's dive right in.
And that whole idea leads to a really interesting question. I mean, have you ever wondered why some mountains, like the Himalayas, are these incredibly sharp, jagged peaks, while others, say the Appalachians, are all low and rounded? It's not just a coincidence. Answering that question is actually the key to unlocking how our entire planet's surface works, and that's exactly what we're going to do. So what's the secret? Well, you can think of it like this giant planet-wide battle that's been going on for billions of years. It's a tale of two forces. You've got one force deep inside the Earth that's constantly building things up, and then you have another force on the surface that's working just as hard to tear it all down. Okay, so let's give them names. The first ones are called endogenic forces. These are the internal guys, the builders, and they're fueled by all that heat deep inside our planet. Then you've got the exogenic forces. These are the external sculptors, and they get their power from the sun and gravity. Seriously, every single mountain, valley, or plain you've ever seen is just a snapshot of this epic tug-of-war between the builders and the sculptors. All right, let's kick things off by looking at the builders. These are the real heavy lifters of geology. I'm talking about the massive, powerful forces that create the biggest features on our planet. We're talking entire continents, huge mountain ranges, and those massive plateaus. So here's a little breakdown. These internal forces, the endogenic ones, are what we call diastrophic forces. Now that's a bit of a mouthful, but just think of it as the super slow, really powerful movements that bend, break, and lift the Earth's crust. And we're going to focus on the two big players here, the forces that build mountains and the ones that build continents. First up, orogenic forces. The name literally comes from the Greek for mountain building, which is a pretty big clue. The easiest way to picture this is as a giant planetary squeeze. You've got these massive tectonic plates crashing into each other, creating this unbelievable sideways pressure. And all that force, well, it has to go somewhere, right? And this is exactly what happens. It's kind of like if you push the two ends of a rug together, it wrinkles up. The Earth's crust does the same thing. The rock layers literally fold and buckle. The upward folds get the name anticlines, and the downward folds are called synclines. And this process, playing out over millions and millions of years, is what gives us the most massive mountain ranges on the planet. And boom, right here, we've just found the first half of the answer to our big question. Mountains made this way can be either young or old. The young ones, like the Himalayas or the Alps, are still being pushed up. That's why they're so high, so steep, so jagged. But the old ones, like the Appalachians, they've been around for hundreds of millions of years and, well, something's been happening to them all that time. But wait, it's not all about squeezing. There's another type of builder force called epirogenic forces. These are the continent builders. Instead of pushing sideways, they act more up and down, causing huge chunks of land to either get lifted up or to sink down. And instead of folding the rock, this tends to crack it, causing massive faults. This shows it perfectly. When the crust gets pulled apart, you get these cracks, these faults, and sometimes a whole block of land just drops down between two of them. That sunken part is called a rift valley, or a gruben. The parts left standing high on either side, those become block mountains, also called horsts. A classic example of this is the Great Rift Valley in Africa. Okay, so the builders have done their job. They've created these awesome, rugged mountains and huge plateaus. But their job is never really done because their creations are never safe. The second, and I mean the very second, a new landform is raised, the sculptors show up and get to work. These external forces, the exogenic ones, are all about one thing: denudation. It's just a scientific way of saying they strip and wear away the Earth's surface. It's a 1-2 punch. First, weathering breaks the rocks into smaller pieces. Then, erosion comes along and carries those pieces away. You could definitely call them the destructive forces, because that's what they do. They break down what the builders created. And what do these sculptors use? Well, they've got a whole toolbox. You've got water. Rivers are amazing carvers. You've got wind, which acts like a natural sandblaster. And then there's ice. We're talking giant glaciers that can literally grind mountains down. So here's the bottom line, and it's the other half of our answer. These are the forces that take a young, sharp mountain and, over eons, sand down its edges and round off its peaks.
So now we get it, right? This epic battle between the builders raising things up and the sculptors tearing them down. So let's take a tour of the gallery and check out some of their incredible handiwork. We've already talked about mountains, so let's see what else they've created.
Okay, first up, plateaus. The best way to think of a plateau is like a giant tabletop. It's a huge area of high ground, but it's pretty flat on top. These are definitely made by the builders, but they are constantly getting carved up and worn down by the sculptors, especially around the edges. And there are a couple of main types you should know. You've got intermontane plateaus, which, like the name suggests, are literally squeezed up between mountain ranges. The Tibetan Plateau is the most famous example. Then you have volcanic plateaus, like the Deccan Plateau in India, which are built up over ages by massive, repeated lava flows, one layer on top of another. And that brings us to our last major landform, plains. These are just what they sound like, those huge, flat, low-lying areas of the world. Now, some are made by the builders lifting the land up, but get this, many of the world's most important plains are actually made by the sculptors. Think about it. Where does all that rock and dirt that the sculptors wear away from the mountains go? It has to end up somewhere, right? Well, rivers carry it downstream and drop it, creating these super fertile alluvial plains. Wind drops sand, creating deserts. This is the amazing part. The destruction by the sculptors actually creates some of the best farmland on the planet, which is why so many people live on plains. And this chart here just ties it all together beautifully. You can see the three big landforms, mountains, plateaus, plains, and how they branch out into the different types we've just talked about. You can trace whether they were made by folding or faulting or volcanoes or by the sculptors dropping off material. It's kind of the whole story at a glance. So, if there's one thing to remember from all this, it's that this isn't just something that happened in the past. It's happening right now. The Earth's surface is totally an unfinished masterpiece. The builders and the sculptors are out there, working away every single day. You know, there's a great line from the source material that just nails it. It says that landforms are symbols of the energy of the Earth. And that's so true. Every mountain, every single valley is basically a monument to the incredible power at play, both deep inside the Earth and right here on its surface. Next time you hear about an earthquake or see a volcano on the news, remember, you're watching the builders at work, live and in real time. And the next time you see a river running brown and muddy after a big storm, that's a sculptor, busy reshaping the world, one tiny grain of sand at a time. And that kind of leaves us with one last big thought. This whole process is still going on. The Himalayas, they're still getting taller. The Atlantic Ocean, it's getting wider every year. So it makes you wonder, what's our planet going to look like in, say, another 100 million years? What new mountains, what new continents are being born right now, right under our feet?